My name is Maxwell George. I'm the project lead for cryotherapy to prevent radiation-induced dermatitis. Team members include Morgan Askew, Thomas Cody, Diamond Coe, John Ranshaw, and Thomas Ryan. Our project supporter is Atrium Health's Dr. Benjamin Moeller. Our project mentor is Dr. Gloria Elliott.
For the Senior Design Project, our team is working together with Atrium Health Levine Cancer Institute to reduce clinical skin irritation of cancer patients caused by the heat from radiation therapy on the surface temperature of the patient, specifically the breast. The team's goal is to design a device that can cool down the skin temperature of the breast to 3 degrees Celsius by a liquid nitrogen-cooled vapor. The apparatus designed and manufactured will be tested in clinical trials to see if cooling the target skin temperature to 3 degrees Celsius during the delivery of radiation therapy could prevent radiation-induced skin irritation. The figure below shows a simple schematic of how the patient will be laying on the radiation therapy table.
For the design requirements and specifications, the prototype should be able to cool the skin temperature of the patient's breast to 3 degrees Celsius, plus or minus 1 degree Celsius. It should be lightweight and be portable. It should also allow a vaporized substance to be cooled to a specific ambient temperature by liquid nitrogen, be easy for nurses to operate, run for approximately 5 minutes, and not touch the radiation therapy machine.
Our prototype design starts with air being released from an air tank through some hosing. The hosing then transitions from the tubing of the air tank to the copper tubing. The air in the copper tubing gets cooled down by the liquid nitrogen bath, which the copper tubing is submerged in. The temperature of the air should be about negative 66.9 degrees Celsius when it comes out of the bath of the heat exchanger. The hosing then transitions from copper tubing to silicone tubing. The silicone tubing is attached to the designed mount, which is also attached to the therapy table. The air travels from the silicone tubing and is then released at the end through a nozzle. The nozzle will be directly above the patient and hit the designated target area. As you can see, Figure 3 shows the delivery system of the cool air to the patient, while Figure 4 shows the mount system that will hold the nozzle over the patient.
The prototype design will also have a feedback system using an Arduino board. The thermocouples will be responsible for sending the Arduino board a signal to start running its code. If the thermocouple does not have the proper temperature, then the system will not start.
Figure 6 is a top and side view of the prototype near the patient.
The team's plans for next semester are to complete additional calculations, complete coding of the Arduino feedback design, to build and assemble a final design, and to complete a mannequin for testing. The expected results are that the prototype will release cool air and cool the skin during radiation therapy, the prototype will automatically stop on its own after a certain amount of time, and that the prototype will be complete for clinical trials for Atrium Health.
Thank you.